So for this next part, I want to go over some problems that you'll see, and you'll see a lot of these when you get into algebra, but you may see a few of them in course 3. So we're going to talk about, we're still on our properties of exponents, and we're still under the LEQ of how can I know and apply properties of exponents to generate equivalent expressions. Um, but I want to talk about what to do when you are working with coefficients. So first of all, let me define what I mean by coefficient. If I have this problem, 2 times a to the power of 3, I have a couple different parts that we've already talked about within this expression. So my a, you all know this, that's what we call the base. This power of 3 is what we call the power or the exponent. And then we have this 2 exponent, yep. Then we have this 2 right here, and that's what we call the coefficient. Okay, so when I'm saying working with coefficients, I'm talking about what do I do when we're working with a whole number just like that 2. It's not an exponent, that whole number like the 2. And in your notes, add all of this, but in your notes, I also want you to treat coefficient as its own base. Okay, treat coefficients as its own base. So now, when I go back and I do that, I see this coefficient as its own base. So the unstated exponent, let's use orange, the unstated exponent there would be like to the power of 1. So I can think of this as 2 to the power of 1 times a to the power of 3. And that's going to help me see and work through these upcoming problems. So I want you to write example in your notes, and we're going to go through a couple of examples together. So here is our first example. So again, I'm going to treat my coefficient as its own base. So I'm going to think of it as 2 to the power of 1. So now I can rewrite this because it's multiplication, and I can regroup, and by regroup I mean ungroup. Okay, and now that's the same problem. I've just added my little multiplication symbol in between there. It wasn't stated previously. So now I'm going to go ahead and I'm going to combine like terms. So I have 2 and 2. When I think about that, I can think of it in a couple ways. This is 2, so 2, I can think of it as 1 plus 1, which is 2 to the power of 2, or I can just think of that as 2 times 2. Either way, I get 4. And then I have x to the power of 3 times x squared, so that's x3 plus 2. So that gives me x to the power of 5. And now I can take these, and it's still multiplication. I bring down my same operation, but I can rewrite them showing without that multiplication symbol. So it'd be 4 times x to the power of 5. And I get the same thing when I expand my x's out. So 1, 2, 3 times 1, 2. That gives me my x to the power of 5. That's still my same answer. Let's show you another example. Here we go. So again, I think of this as 6 to the power of 1 times x to the power of 3, and that's all to the power of 2. Now, according to my power of powers, I distribute this power of 2 to everything inside the parentheses. So I can think of this as 6 1 times, that's a multiplication symbol 2, and then x 3 times 2 because of my power of powers property. Okay, so 1 times 2 is 2. X3, that's a times, make sure that it looks like a multiplication. X3 times 2 is 6. And then I can actually simplify this a little bit more. This is okay, but if I put this 6 squared, so 6 squared would be 6 times 6, which equals 36. And then x to the power of 6, that would be the best final answer. Okay? All right, same thing, let's jump over to this one. Same thing here. So I can treat this as 52 to the power of 1, 13 to the power of 1. Those are fine. Just know that whenever you do something to the power of 1, it is itself. Okay, it is itself. So I can think of this as 52 times x to the 6th divided by 13 times x to the 7th. And then I can go ahead and I can actually split this because I have two different numbers. I can think of it as two separate fractions. So over here, what is 52 over 13, which is the same thing as saying 52 divided by 13. And when I do that, I end up with 4. If I put that back in fraction format, it would be 4 over 1, but I can just think of it as 4. Then here, that's a negative 7. That's important to note. So then I deal with my x's. So let me think about my x's now. And again, that's a negative 7 because that's a negative 7. So I've got x to the 6th minus negative 7. So add the opposite. That gives me x to the 13th. And again, because it's positive, it would just be over 1. So here, I would have 4 times x to the 13th because I'm going to take these two things and I'm going to combine them, put them back because they were combined to begin with, to give me my final answer. Okay, final answer. And again, you're writing all of these examples down. All right, so let's take a look and let's see how this applies. So I've got 7 to the power of 1, a to the power of 3, b to the power of negative 1, and all of that is to the power of 0. So I take this and I multiply. I do my power of powers because they're being multiplied. So I would have 7, 1 times 0, a 3 times 0, and b negative 1 times 0 because I distribute that outside power to all of my inside powers. So then I get 7 to the 0, a to the 0, b to the 0. When I go through and I work that part through, expand it down, 7 to the 0 is 1, a to the 0 is 1, b to the 0 is 1, so that is all to the power of 1. Or that's all 1 because of the power of 0. So that's my power of 0. So going back now, whenever you're dealing with these coefficients right there, you are thinking about the coefficient as its own base. And you are doing, and your examples should now be, they were seen throughout this different lesson. I want to end with one final example, and this is probably the most challenging example, so we're going to go through it one more time. And again, because of my associative property, I can ungroup or regroup in multiplication. So I'm going to go ahead and I'm going to find my like terms. So I have a 3 and a negative 2. They're like terms because they're both coefficients. They don't have any variables like with them. They don't have any, yeah. And then I've got my other like terms include x to the negative 2 and x. And then my other like terms include y and y to the negative 3. So now I'm going to go back and I'm going to start to combine them. So I have 3 times negative 2, or I'm going to start to solve them. 3 times negative 2 is negative 6. That's the first part. Then I'm going to deal with my x's. X to the negative 2nd times x, and I can just put a 1, equals x negative 2 plus 1, which equals x to the negative 1st, which if written without the negative would be 1 over x. And then my y's, oh, wrong color. My y's, did I use this one? I think so. Would be y to the 1st times y to the negative 3rd, which equals y to 1 plus negative 3, which equals y to the negative 2, which equals 1 over y squared. And now I can go ahead and combine them. So now if I'm taking all of my separate pieces, and I'm combining them back together. Remember, my original format was all in multiplication. So I've got negative 6 times 1 over x times 1 over y squared. And I can think of that as negative 6 over 1. And simplified, that looks like negative 6 because negative 6 times 1, negative 6 times 1 is just negative 6. Get this squiggly off. And then 1 times x is x, and then y squared. So that right there would be my final answer on this. Again, that was a more challenging problem. All right, if you have any questions, raise your hand and let me know. Otherwise, go on to your next activity for some additional practice.